trigonometry identities, they ask us to prove that tan theta plus sec theta minus 1 all over tan theta minus sec theta plus 1 equals to 1 plus sin theta over cos theta. This is from left hand side and this is our right hand side. So you can either prove from here to here or from here to here. No, I want to prove from left hand side and it must give me the right hand side. Now they said tan theta plus sec theta minus 1 all over tan theta minus sec theta plus 1. Now, if you check all the trig identities we proved the other time in our previous videos, I'd like you to go and watch one here because it's a game that you need to be very smart. This one is equal to something related to all these things. If you check when we prove for h squared equals to o squared plus a squared, when we use all over a squared, all over a squared, all over a squared, this one is inverse of cos. That is sec square theta equals to tan square theta plus 1. So we say sec square theta, if I bring tan square theta inside, minus tan square theta equals to 1. This one, I want to bring this value. Because sec square theta minus tan square theta equals to 1. I now say tan theta plus sec theta minus open the bracket. This one is equals to this with this L equals to sec square theta minus tan square theta. This one here sec square theta minus tan square theta all over tan theta minus sec theta plus 1. Now let's continue. We can say tan theta plus sec theta minus. Now from our normal mathematics, they give us a squared minus b squared. That is difference of two squares. We are going to have a plus b and a minus b under our normal mathematics. So this thing stands in form of difference of two squares. So I can have minus open bracket sec theta plus tan theta and into bracket sec theta minus tan theta. This one in form of this I have all over tan theta minus sec theta plus 1. Now, if you can observe very well, you will discover that tan theta plus sec theta is one side, like a normal minus, and this one is another side. You will now discover that something is common to the both sides. What is common? Tan theta plus sec theta is here. Tan theta plus sec theta is also on this side. You can factorize it. If I factorize it, I'll just bring out tan theta plus sec theta open bracket 1 because tan theta plus sec theta times 1 will give me this minus, but it's common here, minus open bracket sec theta minus tan theta close bracket and the big bracket. I believe you get that because this one times this will give me this minus here, and this one times this will give me these two back. I just factorize all over tan theta minus sec theta plus 1. Now after that, all we do, we see that we can now open a bracket. I'll just say tan theta plus sec theta plus sec theta into bracket 1 minus sec theta minus and minus plus tan theta all over tan theta minus sec theta plus 1. Now, if you observe very well, we see that 1 minus sec theta plus tan theta also equals to this. Because this is minus sec theta plus tan theta plus 1 plus 1. So this one comes with this. So I have left with me tan theta plus sec theta. Now, if I've gotten this, what will I do with it? If you observe, don't forget that I'm trying to get this back. But to help us, we know that tan theta in our normal mathematics, our tan theta is 12, opposite all over adjacent. Also, tan theta can also be, tan theta is also equal to sin theta all over cos theta. Let me show you. Because sin theta is so opposite all over hypotenuse divided by cos theta adjacent all over hypotenuse. That means opposite all over hypotenuse times hypotenuse all over adjacent. So when we have this, if you multiply the 8 cancel 8, sorry, 8 cancel 8, we have all over 8. All over 8 is what? 12. 12 is also means what? Tan theta. That means tan theta is also sin theta all over cos theta. And tan theta also is opposite over adjacent. Tan theta is also sin theta all over cos theta. Now, this tan theta, I can write it as sin theta all over cos theta plus what is sec theta? Sec theta is what? 1 all over cos theta. I believe you know that. Sec theta from our this thing. You know that sec theta is 1 over cos theta. Because inverse of cos theta is sec theta. That means plus 1 all over cos theta. Now, if I collect the LCM, my LCM is going to be cos theta. Cos theta and cos theta 1. 1 times sin theta, sin theta. Plus cos theta and cos theta 1 times 1. Now, if you see, is it not the same? You got this and it's equal to this. Because sin theta plus 1 equals cos theta. It's always the same as 1 plus sin theta plus cos theta. That means the thing is approved. Let's take one more proof. Now, we are asked to prove that the square root of 1 plus cos theta all over 1 minus cos theta equals to cosec theta plus cos theta. Now, like I said in the previous one that we can prove from the left hand side to the right hand side, or we can prove from the right hand side to the left hand side. I want to prove from the left hand side to the right hand side, and it must equal to whatever we have at the right hand side. Now, we have 1 plus cos theta all over 1 minus cos theta. That means I can rationalize from our sort figures. Like, you know, in the sort, when we have something like this, a all over root a, now this times a all over root a. Now, you can just say multiply by the. Now we rationalize by, you know, the what is the denominator here. We're going to use it to multiply the numerator and the denominator back. That is 1 plus cos theta all over root of 1 plus cos theta. You are permitted to split this square root for this numerator and denominator. That's why I just did it. So if I multiply this one by this now, so that means that I want to multiply this one by this one. I'm going to have square root of 1 plus cos theta squared because I multiply the two numerator together all over. So if you take note, you will discover that this and this, they are minus and plus. And don't forget, when you have a squared minus b squared, what do we have? We have a plus b, a minus b. Now, if I now have this and this now, like this one and this one, I can bring it back to the square. So what will I do? I can just say root of 1 minus, become minus 1 minus cos square theta. That's what I just did for this, and the square root is there. Some people are asking that why this one is not having square. Because I know that 1 square is also 1. That's why I don't bother myself to put this the square here. But as you can see now. Now, if you have something like this, this square can cancel the square root. So that means we have to left with 1 plus cos theta all over root of 1 minus cos square theta. And if you could remember from our proving of trig identities, I said that if you remember that 1 minus cos square theta will give us sin square theta. Now from this proving, h squared equals to o squared plus a squared. We said all over h squared, all over h squared, all over h squared. We said 1 equals to so that is sine squared theta plus k cos squared theta. And I said that I can bring this plus cos squared theta here. That is 1 minus cos squared theta equals to sine squared theta. That means 1 minus cos squared theta can give me sine squared theta. I'll just say 1 plus cos theta all over the square root of what? Sine squared theta. Now, when I have this square can cancel this square root. What do I have left? I have 1 plus cos theta, 1 plus cos theta all over sine theta. Don't forget that we are proving to get this. We have to get this before we stop. Now I can split this denominator under this and this. I say 1 all over sine theta plus cos theta all over sine theta. 1 all over sine theta. Now what is 1 over sine theta? That is cosec theta. That is inverse of sine theta. That is cosec theta plus. And what is cos theta over sine theta? That is cot theta. Cot theta. Because do not forget that tan theta is sine theta all over cos theta. Tan theta is sine theta all over cos theta. So, and we know that the inverse of tan theta is cot theta.
Yes.
So that means if I want to get cot theta now, I can also say cot theta is cos theta all over sine theta because it's the inverse. So that means cos theta all over sine theta is what? Cot theta, and which is also equal to this. That means it is proved. Now they say prove that 1 minus cos theta all over 1 plus cos theta equals, open a bracket, cosec theta minus cot theta, close the bracket, cos squared. Like I told you, this left hand side and this our right hand side. We are permitted to prove either from the left hand side to right hand side or from right hand side to left hand side. This time around, let me prove from right hand side to left hand side. Now, when I have this into bracket cosec theta minus cot theta all squared. As you all know that cosec is 1 over sine theta, right? 1 over sine theta minus, and the cot is cos theta over sine theta all squared. I believe we know that because cot theta is inverse of tan theta, and tan theta is sine theta over cos theta. So cot theta will be what? Cos theta over sine theta. Now from this I can find my LCM. My LCM is going to be sine theta. Sine theta is sine theta 1. 1 times 1 minus sine theta is sine theta 1. That is cos theta. So that means if I want to split it, because this square is meant for denominator and denominator. That means for the numerator we are going to have 1 minus cos theta to bracket 1 minus cos theta all over sine square theta. All over sine square theta. So what does that mean? The sine square theta, if you remember from our first proving that sine square theta can also be equal to 1 minus cos square theta. I believe we understand that. That means I can have, since I will know that, that means 1 minus cos theta all over, again, 1 minus cos theta all over 1 minus sine squared theta. I've changed, 1 minus cos squared theta. I've changed this into this by our first proving. Do not forget that we are targeting this. It's a game. It's something that as you are doing, you have to be watching. And where am I going? Am I eating the point? Am I eating the point? So I know that this thing must be numerator in my answer, and this guy must be denominator in my answer. That means I cannot stop here. So that means 1 minus cos theta and 1 minus cos theta. This guy can also give me into bracket 1 minus cos theta and 1 plus cos theta. Why? I told you it's a difference of two squares. When you have something like this, it can be 1 square minus cos square theta. And difference of two squares, that means it will give you plus and minus. And it will not carry square again as you know. So this cancels this. So we have 1 minus cos theta all over 1 plus